So we're on page 3 of 3.3, not 3.5, because we're going to need that space. Bottom of 3.3, you're going to draw a chart that says supplementary congruent. There are relationships. There are 6 of them. Some of them are supplementary. Some of them are congruent. How many of them were supplementary? Do we remember? 2 of them are supplementary, and then how many of them were congruent? There were 6 total. So how many were congruent? 4. It's okay. So we're going to name them. Please understand that I already have them in like a certain order. So if you don't say it in that order, that's fine. I just will take a second till you say the one that I have. So what is, we're going to go supplementary first. What is a pair of supplementary angles that we have learned? What are they called?
Transverse.
No. A transversal is a line that cuts through 2 lines. A linear pair. Thank you, Michael. Linear pair. You're not wrong. Chelsea, we're just not there yet. Linear pair. So linear pair, they are adjacent, right? They add up to 180. What was the second one? And Chelsea just said it. Consecutive interior. Okay, we'll go through and explain what they are at the very end of this list. So those are the only 2 that add up to 180. All of the rest of them are congruent. They are a linear pair and consecutive interior angles. 4 of them are congruent. Now I want you to know, because you're trying to guess what I said first, it is not the order in which you think it is. But the last one I said was consecutive interior. So the next one I said was alternate interior. Then after alternate interior, what do you think I said?
Consecutive. Congruent. Corresponding.
Thank you, Joshua. Alternate exterior. I said alternate interior, then alternate exterior. He did, someone said it. Then I wrote corresponding. And then I wrote vertical. Interesting order, I know. It is what it is. We're going to go through and review all of them. But I highly recommend remembering which are congruent and which are supplementary. Okay, what we're going to do, I highly recommend having a highlighter out. Make sure your phone is face down and on the corner of your desk, not right in front of you where it tempts you. Wonderful. Here's what you're going to do. At the bottom, we're going to highlight or put a star next to those that prove that lines are parallel. So at the bottom, I would write something that's showing, we're going to note which ones prove that lines are parallel. Maybe we're going to put a star next to them. Maybe you want to highlight them. It doesn't matter to me. But we're going to highlight or put a star next to those that prove, see if you're writing that down, prove that lines are parallel. You learned it yesterday. There are 4 properties that prove that lines are parallel. So I'm going to go through and explain why each of these are or are not enough to prove that lines are parallel. You're like, what does that mean? I will show you. I'm just going to go in order, starting with a linear pair. Name an example of a linear pair here. 2 and, she said 2. 2 and 4, sure. 2 and 4, they are a linear pair. They're both sitting on this line, correct? This is not enough to prove that these 2 lines are parallel because there is nothing happening. There's no information at this second line. Okay? So that's why it is not enough to prove the 2 lines are parallel because both of them are on the same line. The next one is consecutive interior. What does interior mean?
They're on the inside of the transverse.
Inside of the double lines. Yeah. So inside the double lines, what does consecutive mean? On the same side of your transversal. So remember the transversal is one line, I highlighted in blue, that cuts through 2 or more. So consecutive interior would be on the same side and inside. So name an interior angle. 2, what is 2 consecutive interior width? 5. So 2 is sitting on this line and 5 is sitting on this line. So this is why it is enough information, if they're supplementary, This is enough information to prove that two lines are parallel. So go ahead, whatever you used, if you said you were going to put stars next to them, if you said you were going to highlight them, go ahead and note that consecutive interior angles being supplementary is enough to prove that two lines are parallel. So you should either have a highlighted or a star, something to show that this is enough to prove two lines to be parallel. We'll move on to the congruent category. Alternate interior angles. We said interior, again, means inside of the double lines. What does alternate mean? Opposite sides of the transversal. So pick an angle on the inside of the double lines. 4. What is 4 alternate interior with? 5. So 4 sits on this line, and 5 sits on this line. If they were congruent, is that enough information to prove that these two lines are parallel? Yes. So put a star or highlight, however you want to do that. Alternate interior. Alternate exterior, they're just going to be located on the outside of the double lines and on opposite sides of this blue line, this transversal. So pick an angle on the outside. Well, I heard 1. That's the first thing I heard. 1 and 8. So 1 is sitting on, I already have it highlighted, it's sitting on this line, and 8 is sitting on this line. Is it enough information to prove that the two lines are parallel? Yes. If they are congruent, it is enough to prove. So alternate exterior. Corresponding, pick any angle at all. 5. What would 5 be corresponding with? 1. So 1 is sitting on this line, 5 is sitting on this line. So is there enough information to prove these two lines are parallel? Yes. I think I already told you that there's only 4 properties, but either way, we're going to talk about why vertical angles are not enough to prove that two lines are parallel. Pick any angle at all. 6 is vertical with 7. They're both on this line, right? We don't know any information about the other line, so this would not be enough to prove the two lines are parallel. So all it is are the 4 new ones. Those are enough to prove the lines are parallel. That's what you learned yesterday. Okay? We're going to use this information. This is above the box you should have just drawn on 3.3. It says find the value of x that makes line S parallel to line T and explain your reasoning. Guess what? Explaining your reasoning in this section is half of the problem. Okay, so first we're going to talk about what relationship these two angles have. They're alternate exterior. So what would alternate exterior angles have to be in order for S to be parallel to T? They would have to be congruent. So what are we going to do to solve for x? Set them equal. 2 times x plus 10 equals 3 times x minus 8. I'm glad we're doing this because this class struggle bus at distributing. When you distribute, are you adding, subtracting, multiplying, or dividing? Multiplying to one part of the parenthesis or both? To both. So 2 times x is 2x. 2 times 10 is 20. 3 times x and 3 times negative 8. Negative 24. I always move my smaller x, which here is the smaller x, which is 2x. How do I move that positive 2x across the equal sign? Subtract it. So 20 equals 3x minus 2x is x. And then my last step, Reagan, you've got it? Yep. I did, but it's fine. Everything's fine. 20 plus 24 is 44. So you should have 2 things circled. It said find the value of x. Did we accomplish that? Yes. Explain your reasoning. Here is my reasoning. They were alternate exterior angles, therefore they're congruent. In order for these two lines to be parallel, alternate exterior angles have to be congruent. Make sure you have 2 things circled. Some of you don't circle in the first place. Make sure you circle. So be blessed, be thankful, because this used to be, Ms. Westcott used to teach class, and And you would have to know like the actual theorem name. This is called the alternate exterior angles converse theorem. You would have had to written all that out. I would rather you know what the theorem says. And it says alternate exterior angles will be congruent if these two lines are parallel. Capiche? Both things should be circled. In the second, what relationship do these two angles have? They're consecutive interior. So we're going to go ahead and write that in. That these are consecutive interior. What do consecutive interior angles have to be? They do not. Supplementary. No, not for supplementary. Is that what you mean? Okay, so there are two ways to solve this, and most of my classes have opted for the longer way. If they're supplementary, what do I know about these two angles? They don't equal 180, they add up to 180. So this is option 1, which is the option most of my students have chosen. And it's fine, live your life, within reason. What is the second option? Do we know? If I know they add up to 180, I could subtract 120 from 180 and find out what 4x minus 12 equals. Because I know these two add up to 180. If this one's 120, what is this angle going to equal? 60, because 60 plus 120 is 180. So these are the options. Either one are correct. This one, just bless you. This first one, I'm going to tell you, some of us struggle with combining like terms. So this will be my only concern with you doing it this way. Which way do we want to do it? First way or second way? There's no shame. The second way? Sure. All right, so then we would add 12. So 4x equals 72. Divide by 4. X equals 18. So again, you have two things circled. You have x equals 18 circled, or boxed, however you want to say it. But you also have the fact that consecutive interior angles would be supplementary if these two lines are parallel. That's all. Okay, whenever you're ready, you're going to flip to the new set of notes, 3.5. Alright, this section is extremely important for those who have a 3.0 and just a 3.0. In January or February, you take the PERT test, which is the dual enrollment placement test. Even students who don't really plan on doing dual enrollment but have that GPA that they need, they often take the test. This section, because I tutor for the PERT test all the time, this section is on it. So I'm going to emphasize, I split it into 2 days. There's an easier part, there's a harder part. We're doing the simple part today, I guess I should say, and then diving more into it tomorrow. Okay? This is review over linear equations. What is the root word of linear? Line. So linear equations look like a line. So we're looking at, if you have a graph, a line on the graph. We're looking at parallel lines on a graph or perpendicular lines on a graph also. Okay, so first thing we're going to talk about is y equals mx plus b. So here's what you're going to do. In the top right of 3.5, there's like a blank section. Don't write too big, but write in that this is called the slope-intercept form. And then write in y equals mx plus b. It's not really don't write it in the middle. Nope.
Wait, where at?
The top right of your note somewhere.
Right here?
Sure. Because you're going to fill in all of that, though. So it wouldn't, it's fine. Slope-intercept form, y equals mx plus b. And I see so many memes making fun of high school math, and that's fine. But they always include like the Pythagorean theorem, the quadratic formula, or y equals mx plus b. My husband, who has been out of school for 10 years, he knows what y equals mx plus b is. Does he know what it represents? Nah, but he's heard of it. You need to know what it means. This is called the slope-intercept form. And it didn't hit me until I had already graduated high school why it was called slope-intercept form. And here's why. If it is written like this, y equals mx plus b, it tells you what the slope is and it tells you what the intercept is. And I'll explain what intercept is because right now you're learning a lot. So what I want you to do is first highlight the letter M. The letter M, because it represents the slope. So go ahead and highlight the letter M and then write under it that it represents the slope. So when you think of slope, I want you to think of, if you've ever been skiing, which apparently nobody in school ever skis, or snowboard, there are slopes. They're like hills, basically. Yeah. Do you remember what the fraction was when you did slope? It was a word over a word. It was rise over the run. I would also write that in. Rise over the run. So this is why it's called slope intercept form, because there's my slope, it's M. My intercept is B. And again, I promise I will explain it. It is the y-intercept. So go ahead and write in that it is the y-intercept. And I'll explain why that matters to you. It will matter a lot. I tutored a kid in college algebra last week, and they're going over this, literally. Not very much different, just this. The y-intercept is where it crosses the y-axis. So this formula tells you the slope, which tells you rise over run, tells you how much it's going up and over, but also tells you the y-intercept. Okay, so that's why it's called slope intercept form, because it shows it to you. So if it's written in slope intercept form, like this, I just wrote y equals 1/2 x minus 4. What is the slope here? 1/2. All right, so 1/2, and then what is the intercept? -4. So guess where it crosses the y-axis? At -4. So 1, 2, 3, 4, and then it looks something like that. So this is why this is so important, and I'll explain slopes more in depth. If you're not understanding slopes, perfectly fine. We're going to talk about the 4 different types of slopes. Okay, so you're going to draw this across. There's like a big blank section that says types of slopes. You can draw this as big as you want in that blank section. There are 4 types of slopes. There are 4 types of slopes in real skiing. Have any of you ever skied? Did anybody come from that? You have skied. Perfect. Ski or snowboard? Ski. Where have you skied? West Virginia. Very cool. I've been skiing in Colorado, New York, obviously, New Hampshire. I've been in Virginia when I was really little. I don't love it because I break bones and I bruise, and my sister is not good at it. My other sister's very good at it. It's awkward. So there are 4 types of slopes in real life. There are 4 types of slopes here. Okay? This first one, I hope maybe you're from America, maybe not. We read left to right here in the Western Hemisphere, correct? So when a line like this first piece is going up, when it goes left to right, this is called a positive slope. So go ahead and write the word positive. You could think of this like the chairlift. It's going up from left to right, because again, we read from the left to the right. It is going upward. The reason it matters so much that you know this is a positive slope, I'm going to show you the math way to find the slope. If you get a negative slope and the picture look like this, guess what you can think about yourself? That you're wrong. Okay, and then you can fix it. So there's a positive slope. There is a negative slope. This would be like the green or the yellow slope. Again, reading from the left to the right, it is going downwards, going downhill. Okay, left to right. This next one is horizontal. It is called zero slope. So what I want you to write is 0, but after that, I want you to write that it is horizontal make the Z a big deal. Horizontal. I made this a bunny because this would be called the bunny slope in real life. The bunny slope is where you learn how to ski. It also has no incline, so no slope. It has no ice patches. It's wonderful. It's fluffy snow. If you fall, it's a good time. Okay? You fell off a chairlift? That's awkward. I've lost a ski off of a chairlift, but that's about it. I had snow in my boot. So if you look here, okay, this has 0 slope. It is just a horizontal line. Okay. The last one, if you've ever heard of skiing, you know that the hardest slope, what is that one called? Anybody know? It's a black. Anybody know it?
Oh, wait.
It's called a black diamond. It's fine. It's difficult. I've been down one. I did not love my life. I'll explain it. This is called undefined. He was correct. Undefined. And it is a vertical line. When I was about 10, I have 2 biological sisters. One is older and one is younger, so I'm in the middle. My younger sister is very good at skiing. She's not good at other sports, but she's very good at skiing. My older sister is bad at all sports, including skiing. And then I'm good at other things. I'm good at sports. I am not a good skier. I don't like it. So one day, one afternoon, my dad took my younger sister and they went to go do, there's a bunny slope, Bunny slope, super flat. It's like a big open football field with snow. Fresh snow, fluffy snow, super nice. The green is a little more narrow. There's obviously a slight incline. It's where most people stay because, if you're feeling adventurous and you're, not an avid skier, you usually do the yellow. The shapes vary on these. If you're an expert skier, you do the black diamond. They are skinnier slopes and they're curved. So when I went to Colorado, I skied in Breckenridge. My sister and I started on a green slope. And at one point, the black diamond crossed the green slope. I was like 10, and she was like 13. So of the 2 of us, she knew better. Somehow, she directed me onto the black diamond, where neither she nor I would ever belong in our whole entire lives, right? So just to emphasize the black diamond, this is what normal surfaces, if you're looking at like the ground, like our ground is like flat, right? It was like arced like this, and we're in Colorado, we're in the mountains. So what are on the edges of the slope? What do you think? There's like trees. Yeah, there's like, I don't want to say cliffs. I don't want to be like dramatic, but like there's drop-offs. There's like, you don't, right? So you want to stay like here. Like this is, the happy place. Pretend that it looked nice. This is the good place. This is the nicer snow. This is like the icier snow. And if you've ever, ice is no bueno to ski on. Your ski can, or snowboard, can hit a chunk of ice and it's not fun. But anyways, so I was not where I was supposed to be. My dad had told me to meet him for lunch, and I love lunch. I don't like being late, especially for lunch. And so I was so overwhelmed, and I did not know how I was going to live my life. So I just sat on my butt, and I just started crying. And I just started scooting my butt down the mountain, right? My sister left me. She's a very responsible person. Meanwhile, adults are speeding by me. Hey, honey, you okay? Where's your parents? Then the first aid snowmobile comes by. You doing all right, sweetheart? Okay. Wait, no, I'm not. I'm over here crying. I can't even answer you, but whatever. I did make it down the mountain. My dad was mad because I was late. I stayed and I drank hot chocolate with my mom in the snow lodge for the rest of the trip. So, black diamonds, this is what it looks like to me. If you move the wrong way, you're falling. You'll split your legs on a tree. It's not fun. I don't like it. But snowboard is super fun. That one's fun. And tubing. Love it. Fun time. But when your skis, if the slightest move, they teach you French fry, where your skis, stay like this. That's if you want to go fast. Or they teach you pizza, or if you want to go slow. Or slow down. I live with pizza, right? But if your skis cross the wrong way, then it's fine. Everything's fine. But anyways, this is what it looks like for a black diamond. Straight down, undefined. Heaven help you. But this is a bunny slope. Look how nice it would be to ski on that. That's so nice. No, we use the sticks. Anyways, so there's that. We are going to talk about finding a slope. Using a slope formula, it's not new to you. You'll see a space for slope formula. I will tell it to you. I'm going to explain it to you first and then show it to you. You're going to write M because what did M represent? the slope, right? Y equals mx plus b. So m is the slope. So remember that slope is rise over run. This is not new information, right? When we're talking about rise, which axis rises? The y-axis. So guess what? It is y1 minus y2. Because rise over run. Y1 minus y2. And then run, when you run, you go left or right. So this will be x1 minus x2. Here's what matters. The y's have to be on the top because it's rise first, run second. Okay, you rise out of bed first. I hope you don't just, I don't know what that would look like. Rise, and then the same thing is the top and the bottom have to be from the same coordinate. So if you see it says y1, x1, and then this one says y2, x2. Same coordinate. So, again, I'm from the Western civilization. I'm from the United States of America. So I am going to read left to right. A is going to be my first coordinate. So I'm going to call that one x1, y1. And x2, y. Whoop. Sorry, I hit the next button on accident. Man. All right, now that we're back. What is my first y? 2. And my second y? 8. All right, and then my first x? 3. And my second x? 6. All right, 2 minus 8 is? -6. 3 minus 6 is? -3. So, yeah, what's a negative divided by negative? Positive, and then 6 divided by 3 is 2. So you're going to write m equals 2. I'll explain it on here. Why? That is the answer. So remember that slope is rise over run? This is a whole number. What is invisibly under all whole numbers? 1. So when we say rise over run, this is a positive 2 and a positive 1. So rise, I'm going to rise 2, a positive 2. Is that up or down? Up. And then I'm going to run is positive 1. Remember that when we run, we're going left or right. Left is negative and right is positive. So when I say positive 1, I'm going to go to the right. So from this point, this is not necessary. I'm just showing you why this is the answer. To stay on this line or draw this line, you would go up 1, 2, over 1. And there I am on the line. So 2, 1. Up 1, 2, over 1. Up 1, 2, over 1. So that is why this is the slope. Okay, so you should have m equals 2 circled. Please understand this, because I've seen this too many times. What is 6 divided by 3? 2. Because 6 is on the top, right? So that would come out to a whole number 2. This says 3 over 6. What does that reduce to? 1/2. Please understand, if you eat 3 out of 6 slices on a pizza, you only ate half the pizza. You did not eat 2 whole pieces. So keep a track of where the bigger number is, okay, when you're reducing. Whenever you're ready to flip, you can. You're going to use that highlighter in 2 seconds because this is probably the most important part, this concept. This section is called Equations of Parallel and Perpendicular Lines. We know what parallel lines look like, right? What do they look like?
They don't intersect. Like they're side by side and they're coplanar.
They're coplanar and they don't intersect. Yes, they're side by side, all that jazz. So go ahead and write that in. They're coplanar, never intersect. That's what they look like. We'll talk about their graphs. We'll talk about their graphs. So the next box where it says parallel lines have blank. I would highlight this. It is the most important part. Your quiz is going to flat out ask you what kind of slopes parallel lines have. And it's one of the 10 questions. So guess how many points it's worth on your quiz. It's worth 10. Parallel lines have the same slope. And I'm going to show you why. Parallel lines have the same. Okay. So if you look at my first picture, we're going to decide what the slopes are first. So are they positive or negative slopes?
Positive.
They're positive. Okay, I'm going to zoom in for a second. Here's a point on both lines, right? So this first point, as it goes towards the next point, it rises how many? To go from this point to this one. It rises 1, so it goes up 1, and then over how many? 2. Up 1 over 2. So what slope is that? 1/2. Up 1, rise 1 over 2. The same thing with the bottom. Up 1 over 2. Because as one of them goes up 1 over 2, they're doing it at the same time. So they always stay the same distance apart. Because if you look at every single point, how far apart are they here? How many boxes? 1, 2, 3, 4. They're 4 apart here. 1, 2, 3, 4. They're 4 apart here. Does everyone see it? They stay the same distance apart. 4 is not anything to do with their slope. It just shows they stay the same length apart, same distance. Okay? Going back to y equals mx plus b for a second. So y equals mx plus b. What is the slope here? We've already found it. We said it was 1/2. What did b represent? The y-intercept, where it touches the y-axis. So where does it touch the y-axis on this first one? Positive 1. But this second one, it has the same slope, right? Up 1 over 2, up 1 over 2. Where does it have its y-intercept? -3. So parallel lines, what they're going to have in common is that they have the same exact slope. Okay? Our picture was positive. Our slopes were positive. Looking at the second picture, what do I know about both of my slopes?
Negative.
They're negative. As they go left to right, they're going down. So they're negative. I'm going to find a point there, 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 and there. So when they rise, so I read from left to right again. When I rise, I'm putting it in quotation marks. When I rise, am I going up or down? I'm going down because, again, I read left to right. So I'm going to go down how many? 3. And then over, that's -3. And then over 1, 2. So their slopes are -3, 2. Okay? One thing to remind you about fractions, -3 over 2 and -3 over 2 and 3 over -2. Are these all different? No. They're all the same. It does not matter where your negative is. Does it matter if I had 2 negatives? Yes, because what's a negative over a negative? A positive. Okay? Reagan, what's your question? How can I help you? Were you about to do the why it wasn't a -2?
No, I was going to say, how did you figure point that's where they intersect?
That's just where they cross 2 lines. Yeah. Okay. So the last thing we're talking about is perpendicular. So yours says perpendicular slopes. Does not matter. You're going to highlight this one too. I put this down into layman's terms. I don't think you'd use the same terms in Miss Johnson's class. I don't know when you learned this or if you've already learned it. But there is a technical word, but we're going to use a word you would use. Okay, so perpendicular slopes, they're opposite sign and the flipped slope. 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 So I'm just going to show you an example. Perpendicular to 3 would be the opposite sign. Is this 3 positive or negative? Positive. So the opposite sign would be negative. And then it says flipped. What do we know about every whole number? What is it invisibly over? It's over 1. So when I flip 3 over 1, what does that become? 1 over 3. So this perpendicular to positive 3 is negative 1 over 3. They're the opposite sign, and then you flip it. Same thing here. We got negative 1/4. The opposite of negative is positive, and then flip 1/4, and it is 4. You do not have to write over 1 because we are educated folk. Negative 6 over 5. Opposite sign would be positive, and then flip it, you get 5 over 6. Okay? So what happens is they look like they intersect and form 90, which they do. And their slopes, if you look, here's the slope. This is why y equals mx plus b is so important. I know it's teeny tiny. This is negative 1/3, and this one is 3. We just talked about that. Opposite sign, and then reciprocal. They intersect. This right angle I drew, you don't have to draw it. This other one we'll talk about. It says y equals negative x minus 3. And this one is y equals positive x plus 1. So this first one up here, what is the slope? X is not the slope. What number is in front of x? Negative 1. So remember, when we are educated geometry students, you don't write 1x. It is just, we know that it's there. Whenever you see an x, there's a 1 in front of it, especially negative, there's going to be a negative 1. What about this other one? What is the slope of the second line? Just positive 1. Here's why they are still opposite reciprocals. What is the opposite sign of negative? Positive. What is 1 invisibly over? 1. And then when you flip that, it's still 1. Okay, so that's why these two are perpendicular to each other. If you took a sheet of paper and you lined it up here, this forms a right angle. Okay? So here's what we're going to do. This is the last question we do before we tackle our homework. It says determine which of the lines are parallel and which of the lines are perpendicular. So what you are going to do is find the slope of each line. You are not going to count. We are going to use the formula. Okay, so starting with line A, because we're just going to go in order because that's what we're going to do. Starting with line A, I do want you to write the formula first because we are practicing. Line A, it's in blue on mine, it's in black and white on yours. All right, so again, I read left to right. I'm going to label the point on the left x1, y1 because it's the first one I would look at. It's negative 2, negative 2. See it? And then 0, 2, I'm going to label x2, y2. All right, what's my first y? Negative 2. And my second y? Just 2. Yeah. My first x? Negative 2. And my second x? 0. Your answer has to be a fraction if you plug this into your for function. It is not going to keep it a fraction. You need to do it. Minus 2 makes negative 4. So just reduce. Minus 2 minus 0 is negative 2. What is a negative divided by negative? And then 4 divided by 2 is 2. So we know the slope of the first is 2. I'm going to make this a little smaller so I can have room. We're going to do the next line. I'm just going to go in ABC order because I feel like life is easier with some order. We're going to do y1 minus y2 over x1 minus x2. y1 minus y2 over x1 minus x2. So again, I'm going to read left to right. So my x1, y1, I'm going to use 0, negative 1. And then my x2, y2, I'm going to use this 0.23. All right, so what's my first y? Negative 1. My second y? Just 3. It's okay. I'm going to plug in x, my first x, which is 0. Then my second x, 2. Minus 1 minus 3 is negative 4. And then 0 minus 2 is negative 2. And again, negative 4 divided by negative 2, positive 2. Good. So we already have one of our answers off the bat, don't we? We want to decide which ones are parallel and which ones are perpendicular. We know if they have the same slope, which one are they? They're parallel. So we're going to say line A. How do I say is parallel to?
2 straight lines.
2 straight lines. Line A is parallel to line B. It's not our final answer, so we want to list Some of them will have more than one. Some of them will have a couple of them being parallel, a couple of them being perpendicular, things like that. So we're going to do line C. We're almost there. So again, I'm going to do 3, -1 as my first x and y. y1 minus y2 over x1 minus x2. What's my first y? -1. And my second y? 2. My first x, 3. My second x, 4. -1 minus 2 is 3 minus 4 is -1, and then that's a positive, and that reduces to 3. We've got one more, and it's line D. So as it looks, at first glance, it looks like there's only one point on it. Where's the second? The 0, -1. They share that one. So both of these, I outlined them in black. So I'm going to say -3, 0 is my x1, y1. And then 0, -1 is my x2, y2. So what's my first y? It is 0. My second y? -1. When I plug in that -1 and there's already a negative, this one's attached. This one is this point. This one's, we're looking at this point and this point. Sorry, it does become positive. All right, my first x. It is -3. And then my second x, 0. I know they're really close together. Maybe if you had highlighters, you could highlight them to be colored like mine. That would be possibly helpful to you. Or just focus. 0 plus 1 is 1, and then -3 minus 0 is -3. So line C, how do I say is perpendicular? Upside down T. Line C is perpendicular to line D.